Hi and Assalamualaikum. Today we will talk about asymptotic approximation using Bode plot. The log magnitude and phase frequency response curve as a function of log omega are called Bode plot or Bode diagram. Sketching Bode plot can be simplified because they can be approximated as a sequence of straight lines, as you can see in this figure. Straight line approximation simplify the evaluation of the magnitude and phase frequency response. The frequency response of a system whose transfer function is given by Gs is G omega, Gj omega equal to Gs as equal to J omega. So this is actually frequency response. So here we are going to plot the frequency response. So the G omega W can be represented in terms of magnitude and phase. So it can be plotted in several ways. There are two of them. The first one is the function of frequency. Second one is the polar plot. So for the function of frequency, there are two graphs, so which is the magnitude and phase. Also for the polar plot, there are magnitude and the polar phase. When plotting separate magnitude and phase plot, the magnitude curve can be plotted in decibel dB versus log omega, where dB is equal to 20 log m. So this is a sample of a semilog paper that been used for the drawing of the Bode plot. So in the semilog paper, we can write the x-axis as the frequency in radian per second and the magnitude in dB. So if you can see that each this fine line here is representing by a number. In this case, a sample that we will choose, the lowest value is 0.01. So we have here, so this is 0.1 and this is 1, 10, 100, 1000 and 10,000. So if you can see here, if here is 1, then this second line is 2, 3, 4, 5, 6, 7, 8, 9 and 10. If here to here, we can represent as 10, 20, 30, 40, 50. If it is here 100, so this is 200, 300, 400 and 400 and etc. Usually when we draw a Bode plot or Bode plot, there will be two graphs, which is the magnitude. So we have the frequency here and we have our magnitude here in terms of 20 log m. It means that in dB unit. And at the bottom one is representing the phase in degrees. So usually we will start at 0 depending on the transfer function degree afterward. And here the frequency should be the same as the magnitude. So we have magnitude and phase, so we should have the same scale. If this one is 0.1, 0.1, 1 and 1, 10 and 10, 100 and 100. So let's sketch. So the general terms in GS consists of S, 1 over S plus A, 1 over S plus A, and this is for the second order, and 1 divided by the second order. So for the first one, S, so we can draw this factor of J omega by magnitude and phase. For the magnitude, there will be a line starting at 0 dB. The intersection is at dB omega equal to 1 here, and the graph will have a slope of 20 dB. So I will teach later how to get this 20 dB. And the next one is for the phase. So the phase will be 90 degree all over the scale. So if you have S here, S is actually J omega, and it will, for the magnitude, it will have a slope of 20 dB, and you also have the phase of 90 degree. That is to remember and understand. If you refer in the semilog paper in a clearly form, so we have here 0, okay, so the intersection will be at frequency at 1 here, And in order for you to get that 20 dB, so you see that at this dB line for magnitude, we're scale starting at 0, so we have 20, we have minus 20 here, we have 40 up there, and minus 40 down there. In order for you to get that 20 dB, you just need to check from the scale, from this one, so the scale before or the scale after, you need to make sure that the slope is coming down at 0 to 20 here, okay, for this loop. So here it will intersect at minus 20 here, and going up here at 0, so this is actually 20 dB, okay, 20 dB here, okay. And also for the face, there will be no problem. In this case, we will start the scale at 0 for the face, 45 minus 45 and 90. So in this case, for S, the face will be 90 degree all over the scale. The next one is 1 over S, inverse from the first one. So what the difference is only in terms of the slope direction. So this will be at minus 20 dB. So the slope previously is at this side, will be at the other side, opposite side, to represent minus 20 dB. And for the face, it is also inverse. So previously is 90, and this will be minus 90 degree. So you just have to remember only one. If S, it will be 20 and 90. If it is inverse, and it will be minus 20 and minus 90. So that is the tips. So in terms of the semilog paper, so you can see that the same thing happened here. So the intersection is at 1. Okay, in order for you to have the minus 20 dB, so from this side, so you have 0 to 20. Make sure that for the scale, so you have here is at 20. You have 1 here, so you just make a line here, and then you can just draw the whole line there. So you will have minus 20 dB. So remember that 1 over S is minus 20 dB. And for the face, so you will have minus 90 degree. So tips to remember, if it's 1 over S, it is minus, and here also minus. And this is just a comparison to show you the difference between S and 1 over S. So the direction of the slope of 20 dB, and it is minus 20 dB. This will be 90 degree for the S, and for 1 over S is minus 90 degree. And this is actually the drawing for S plus A, and also for GS1 S plus A. Okay, for S plus A here, that you can see that the frequency start at 1. Okay, before that it is always 0 until you meet 1, and then at 1, then you will have a slope coming up called plus 20 dB. Okay, so here the frequency is actually over A. And also for the phase here, for S plus A, so you can see that starting at 0.1, so we will have a slope coming up at 45 degree. So from this scale to this scale, you will have 45 degree here. Make a line over here, and then just move up, and then stop at this the next scale, and then it will be flat again. So this is the center of the frequency phase. Okay, next for 1 over S should be reversed from this one. So if this is going up, for 1 over S, from the same point it will be coming down. And also for this one, if it start 0.1 and 1 and 10 going up, at this part you will have going down at 0.1, 1 and 10, and then you will have a flat. So this is 0, you have 20 dB here, and then you get 0 back at 10. And also for this one, you have 0 here, and then you have a minus 45, and then you will have a flat here. Okay, sorry, this is 45 degree. Okay, that's it for the sketching. So this is a summarize of Bode plot table for several type of factor. So usually I will refer to this table for plotting. So if you have j omega or s, the slope will be 20 dB starting from the intersection of 1. So the polar will be 90. If 1 over j omega, it will be another side, which means it's minus 20 dB per decade. So the phase will be minus 90 degree. You have 1 plus aj omega, or you will have cross section is at 1 over a. So the starting from this crossover frequency, so it will be going up at 20 dB, and also for the phase, it will start at 0.1 over a, 1 over a, 10 over a. So we'll have this 45 degree, and if 1 minus aj omega, it will be crossover at 1 over a, so it will be 20 dB also. And then the difference is on the phase shift over here. If you have 1 over 1 plus aj omega, so you will have at 1 over a, you will have crossover here, and then it will come down at minus 20 dB. And also this is the phase 1, and if this is for minus, the same thing for the magnitude, however different the phase. Okay, and this is for the second order, so you have something like this. So this is actually a guideline. So the first thing that we need to do is to make sure that all the transfer function is in this kind of factor format. So j omega 1 over omega, so that we can use these lines to construct our Bode plot. So we will start with exercise. So meet you in the next video. Okay. So hope that you can understand the basic of sketching the Bode plot.